ensure that data is delivered immediately without waiting for buffers to fill. And it is also crucial for the real-time and interactive applications. And here in this example, we can see that bidirectional data transfer begins. Both client and server are going to send an acknowledgement and data. And client sends 2000 bytes of data. A client is sending in two segments. One is 8001 to 9000 and the other one is 9001 to 10,000. And client sends one additional segment. And first three segments carry both data as well as acknowledgement in this three. And last segment carries only acknowledgement. There is no data in this segment. And we use a push flag. This push flag is mainly used to ensure the data is delivered immediately without waiting for buffers to fill. Here we are going to use a push flag. So this is the data transfer phase. It's an example of data exchange. A client sends 2000 bytes in two segments, and server sends 2000 bytes. This third segment is the data from server to the client side. And finally, and then last one is the acknowledgement segment. So before having any communication between client and server, we should have a connection establishment phase and this data transfer phase, and final last one is connection termination phase. The next one is pushing the data. As I said, pushing the data is to avoid delays in the transmission. So in real-time or interactive applications, we use push operations. We send application request by using push operation. Whenever the push flag is set, it indicates that the particular data segment has to be delivered immediately and do not wait for any more data. And the next is urge flag, URG flag, that is urgent data. So some applications need to send data that requires immediate action from the receiver, interrupting any remote processes. In such case, TCP uses URG flag. This main purpose of URG flag is to indicate the presence of urgent data in the segment. The urgent data is placed at the beginning of the segment, and an urgent pointer field is present in the header, which specifies the last byte of the urgent data. You can see here. And the next last stage of TCP connection establishment is connection termination phase. Connection termination phase, we are going initiated by either of the parties, either client or the server. And here we are going to set the fin plus acknowledgement. We are going to set. The first is the client sends a segment with the fin flag is being set, and this indicates that client has whenever a fin flag is set here, it indicates there is no more data to send from the client. The segment consumes a sequence number here. And from the server side, we are going to have an acknowledgement to confirm the receipt of the fin flag from the client side. The server also sends its own fin to indicate that it is closing its side of connection. This is often combined together and we call it as fin plus acknowledgement. And finally, we send an acknowledgement from the client. This client sends an acknowledgement to confirm receipt of server's fin flag. This final acknowledgement does not consume any sequence number here. So the sequence number is consumed in the fin flag, which is set whenever we are sending from the client side. And whenever we are sending acknowledgement from the client side, no sequence number is being consumed. So this is the connection termination phase in TCP handshaking mechanism. And the last is a half close. It is a scenario where one end stops sending data but still can receive the data. So in this example, we can see the right side figure. Client sends a fin say, flag to stop sending, but the server continues sending data. The connection remains open in one direction until the other party also sends the fin flag. So here, whenever a fin flag is sent from the client, an acknowledgement sent from the server, that connection is closed in the client side. But the server still can send the data. And here we can see this block, gray color block indicates that data segment from server to client and acknowledgement from client to server is sent. Now, whenever a fin flag is set from the server side, an acknowledgement is received from the client side to the server, it indicates that the server also want to close the connection and stop the data transfer. So half close indicates that one end can stop sending the data while the other end is still receiving. This is called half close. In this diagram, the half close is client stops sending the data and server still sends the data segments from server to the client side. And for connection reset, we set the RST flag. It is used for abnormal termination. Generally, if we want to deny a connection request, we abort by existing connection or terminate an ideal connection immediately without the formal fin handshake. So in that case, we use this RST flag. So this is all about the TCP connection establishment. So TCP connection establishment has three phases in handshaking mechanism. First is prior to data transfer, we have connection establishment, data transfer, and connection termination. It follows three-way handshaking mechanisms. Uh, in three-way handshaking mechanism, we are going to first have a passive and active open, passive open from the server side and active open from the client side. And to establish the connection, we use three segments, that is sync and sync plus acknowledgement from the server and acknowledgement from the client. And we perform the data transfer phase and after that connection termination. Thank you.